So in this presentation, we're going to look at the difference of proportions and carry out a hypothesis test. So the difference in proportions of two populations. And so we have two samples, one from one population, one from another population. And we're looking at the proportions of both samples, and we want to see if we can sort of infer from those samples if there's any difference in proportions for the populations that they are drawn from. So our populations are first-time convicts and also serving at least 3 years. Okay, and then first-time convicts serving less than 3 years. Okay, those are two groups. Okay, and what we're interested in is the proportion that reoffend. Okay, so we have two samples here, 163 out of 100. First-time convicts serving at least 3 years reoffended, whereas 70% of 140 first-time convicts serving less than 3 years reoffended. Test the null hypothesis that reoffending rates do not depend on the length of the first sentence at a significance level of 5%. So in this video, we're going to use this 4-step approach for hypothesis testing. This is when you would use critical values. There are other approaches to hypothesis testing, but this approach here would sort of assume that you have some sort of statistical tables available to you in the exam situation, and probably also a formula sheet. Now it's increasingly common to do the hypothesis tests in other ways, so this video may not suit you, so you'll know soon enough. Anyway, so we're going to follow these 4 steps. I'll let you have a quick read of that there. Pause and have a quick read of that video, but okay. So we're interested in the difference in reoffending rates between the two groups of convicts. Depending on the length of the sentence, we have two groups of convicts. And essentially, is there a difference in reoffending rates? Okay, so no difference. Okay, so the population proportions, which is reoffending rates, you can just write something like that in, are equal to each other or they're not equal to each other. Okay, so there's two ways of stating the null and alternative hypothesis. Now just actually put in a little sentence there. So just actually make your statement about a mathematical statement about your hypotheses. Pi 1 is the population proportion for one group, pi 2 is the population proportion for the other group, where the proportion is the reoffending rates. Okay, they're equal to each other or they're not equal to each other. So also a little statement here about what they are, what the two hypotheses means is also useful. Okay, now you can also equivalently write this out in terms of the difference of proportions, which is really what we're interested in. So this is directly mathematically equivalent to what's above, but we just express it in terms of the difference in proportions. Is it 0 or is it not 0? Okay. Now the reason for that is it makes it crystal clear what the expected difference is under the null hypothesis. A single numeric value, here it is 0. And that's what we're going to use later on, the expected proportion under the null hypothesis, or the expected difference in proportions under the null hypothesis. So firstly, what we'll do here is calculate the test statistic, and first off we'll use the point estimates, and what we will find is that it's 63% and 50%. That's fairly quick to do. And the difference is, the point estimate is the difference in proportions between these two groups. Okay. P1 minus P2 is 13%. Okay, so there's 13% difference in proportions. Okay, now so this is the standard error formula, and this is a big part of the test statistic. Okay, and this is particularly used for hypothesis tests. And what I'm saying by that is that there's actually a different one for confidence intervals. It's confidence intervals. So it's very similar in terms of construction. So what we have here is P bar times 1 minus P bar times 1 over N1 plus 1 over N2. So it's a bit of a work there. Now P bar is the overall proportion. This is the overall offending rate, and for all of the people in our sample, all of the convicts in our sample. So it doesn't really take into account whether or not they have offended, just treats them as one big group. And we have 133 out of 240, which is 55%, 55.41%. What I'm going to do actually is I am going to use percentages in my calculation just to make life a little bit easier. Just as a quick remark, if I'm using percentages, I have to just slightly adjust that to 100 minus p bar, okay, in terms of percent. It's essentially the complement of the complement of the overall proportion of the, okay. So that is 55.41 times 44.59 times 1 over 100 plus 1 over 140. Now the reason I use proportions is it makes this part of the calculation much easier. Okay, so I have two bits of calculator work to do. Okay, multiply out 55.41% by 44.59% and 1 over 100 plus 1 over 1.70. Okay, so I end up with 2,470.732 times 0.01714. You don't really have to go to so many decimal places as I do. It's just I'm just sort of doing it for extra clarity. So when you're doing it, you know how close you get to me. Okay, in terms of calculator accuracy. So when we multiply those out, we get the square root of 42.3483, which is 6.5075. So 6.5 essentially. Okay. And the test statistic follows this general structure. The point estimate minus the expected value under the null hypothesis, or the expected difference in proportions under the null hypothesis in this case, and divided by the standard error. And just as a quick remark, something you probably should mention here, is to say that it is a Z distributed standard normal random variable. Okay, so that's probably just for extra clarity. Okay, where TS is distributed as a Z normal random variable. So test statistic equals 13 minus 0, which is the expected value of the null hypothesis. Okay, we expect no difference. Okay, or a difference of 0. 13 minus 0 divided by 6.505, that is 1.9976. So we can actually just call that 2.00, because you usually sort of would look at these numbers to two decimal places. Okay, so the critical value, I'm not going to go into so much detail on this because there's quite a lot of work here, and it changes from it changes a lot. Actually, no, it doesn't change a lot. But you actually will be doing similar sort of work with regard to confidence intervals. So essentially, it's based on, we get our value from statistical tables, and the value is determined by using alpha of 0.05. The sample size is at large, and the number of tails in the test is a one-tailed test or two-tailed test. So in this case, we have a large aggregate sample. That means that's relevant. Okay, the test is a two-tailed procedure. Okay, why? How do I know that? Because it's equal to versus not equal to. Okay, that's a two-tailed test. Essentially, how do you tell how many alternatives does the null hypothesis gives you? How many alternatives does not equal to give you? It gives you 2, equal to, greater than or less than. That's just a quick way of remembering it. So just to sum up, the critical value here is 1.96. And really, once you get used to these, you'll sort of see this number pop up a lot, particularly when the alpha, the significance level, is 5%. Actually, almost entirely when the alpha is 5% for large samples. So the decision. What are the conclusions? Well, we failed to reject the null hypothesis in one case, or we failed to reject the null hypothesis in another case. And this is really a statement about evidence. Okay, it's not a statement about truth, if something is true or not. Hypothesis tests are not proofs; they're statements about the strength of evidence. So you have to go beyond that or continue your research. Like, you don't sort of stop when you hit one hypothesis test and get a result you like. You have to keep going and keep checking. So in this case, our test statistic is going to be greater than our critical value. Okay, in that case, we reject the null hypothesis. And that's essentially what happens here. 2.00 is greater than 1.96. So we reject the null hypothesis. There is significant evidence of significant difference in terms of reoffending rates between the two groups of convicts. Okay, and actually a statement like that at the end, a statement like that at the end is helpful. My pen is slipping there. I'll tell you what, I'll just leave it there. So a statement, just to conclude, a sentence. Reoffending rates. Just to conclude that, okay? You can just write it in your own words. Okay, so that's good. We'll leave that there.